Okay, today we do heap memory management. It's called a free store sometimes. It's a loose term. In other words, we're going to create objects in a piece of memory explicitly by the programmer, and we're going to delete the memory when we no longer need it. This is in contrast to stack-based memory where, for example, the automatic variables you've seen in the C part of the course were created on the stack and deleted automatically from the stack when the function in which the variable is defined goes out of scope. Now we're doing something completely different. So it's a bit like the malloc and free in the C course as well. So we're now going to talk about C and dynamic memory, which is just a review of malloc. It's not so interesting anymore because we're using C++. So there are two ways to create memory, or two types of objects. Single objects, for example. So you want to create a single object on the heap and delete it, and also creating arrays. Now we've got good news and bad news. The bad news is you have to learn all the ins and outs of pointers. Good news is you don't have to apply all the knowledge you know about pointers every day in every line of programming, because first of all, many of the arrays and STL containers you will be using takes care of memory management for you. And secondly, in the later section in Boost we'll be talking about smart pointers, and smart pointers alleviate some of the problems you have when allocating and deallocating memory. So it's not too bad. A word of advice would be, certainly in the initial phases of learning C++, don't try to become an embedded device driver programmer and look at all the ins and outs of things which can go wrong. Just be careful and take it step by step. Okay, well, that's my opinion. If you really want to become an out and out programmer, that's something else, but your objective is, as a computational finance student, to learn how to price simple options and using a number of techniques. Okay, so here's the good old C way, the malloc way. You remember the good old days of malloc, and so here we've got an example. I've got a pointer to an integer. So P is a type. We talked about it already. So you got a pointer. It's what do you call it? It's just a special type, and we have to allocate memory for it as well. So we just say malloc and the size of int. So we create one integer of its size, the size of operator you've seen already. And because malloc returns a void pointer, we have to cast it to an integer pointer. And so we do something. So there's a memory allocated on the heap, and we just free the memory. We can allocate 10 integers. So we just say 10 times the size of int. So these are 10 integers on the heap, and we just have to cast it as before, and we just say free P. So we're forgetting about this now. We're now talking about memory management using C++. So it's basically new and delete. These are the only two operators you need to know. These are operators, and it's very easy. Again, as before, I've got a pointer to an integer. It's got no value, so if you try to dereference it and print the value, it'll give a runtime error. We can show you in a moment. Okay, just let me write up. Deallocation. After it, you don't need it anymore, you just delete it. So you have to explicitly delete PI because it's called the pointee. The memory is the pointee, so you have to delete the memory. The PI variable is just a normal stack variable. It's a pointer type. This will be automatically deleted. Okay, but we're not just interested in creating integers on the heap. We want to create our own data types on the heap. So later on, this could be something else. Could be portfolio or PDE or Monte Carlo pointer or something. But now we have the simple example again of a user type. So I've got a PP is a pointer to a point, and this should be PP actually. Just let me change it in real time if I can do it. PP. So that's just in time debugging. Okay, there we go. It looks a bit better. So we create the object dynamically. So there's a new point on the heap. What's the value in the point is the default constructor. So that's the difference with the creating integers or built-in types. The default constructor is called, so there is a value. If you want to deallocate your memory, you say delete pp, and when you say delete pp, the object is removed from memory, but its destructor is called. So if you have a print statement cout in your destruct, you'll see that the object is deleted, and we see it in the test program in a minute. So that's very easy. You declare your pointer, you assign your pointer to a new piece of memory, and you delete it. Actually, the first two lines here you can do in one line. So you can say pointer pp is new point in one go. Other constructors. So again, I'm talking about user-defined types. Let's say I don't want to call it default constructor. I want to call the constructor with two numbers, for example, some other constructor. Again, I do the same as before. A pointer to a point, and I say new point equals the default constructor. I delete the memory again, and I reallocate the memory. So now I call a point with 10 and 30 as input parameters, and now I delete my pp. So that's fine. So I can call arbitrary constructors here for single objects on the heap. Just one remark: if I had forgotten to delete the pp here, what happens is he will reserve a new piece of memory again on the heap, but the old memory will be lost, so it's inaccessible memory, so you'll never be able to recover the memory again. So you got a problem. Let me draw a diagram here. So let me draw my heap. Here's my heap somewhere. I've got my pp. This is the pointer pp, and the first one that creates a new point. So it's got two. It's got x and y coordinates 0. So originally my pointer is pointed to here. You see. So I delete it. You see here, delete. He actually breaks off the link and he cleans up the memory. Now we go to the new pp, new memory. So 10, 30. So the x coordinate will be 10, the y coordinate will be 30. So I just delete it. Everything's okay. But this was the first delete. So if you did not have the first delete, this guy was gone. This guy would still remain in memory. So you go to the next one. So this one is floating around in space. It's lost in space. So you have to be careful. Basically, to make a long story short, every new should have a corresponding delete, which is a good rule to adhere to. So if you've got a new, have a delete, and new delete, new delete. Using pointers to object. Once you get a pointer to an object, we use the pointer notation. You've seen it in the C part of the course already. So again, I got my pointer to a point, a new point. I want to call a member function to my pp. I can either do it set x in this particular case, so we're setting the x variable to 10 in this particular case. So I can say pp pointer set x, or I can dereference pp and do again my dot notation set x, whatever you like. Personally, I prefer doing dereferencing because it's a bit more readable, and in some cases you have to do dereferencing because we got sometimes a whole concatenated list of functions and objects and whatever. So sometimes the pointer just he gets confused, the compiler. So that's how we use the pointers to objects. Now I want to create arrays. So basically, let me draw my heap again. So again, I got my pointer pp on the stack. So it's just a pointer type. But on my heap, I think the heap is a bit more organized than what I've drawn in general. So here it's probably one dimensional or something. Okay, so here I create an array of length 10. So my pointer is pointed to the beginning of my array. So here's index 0, index 1, index 2, up to index 9. Okay, so again it's the same as before, but now I create 10 points on my heap. In other words, he calls the default constructor 10 times. So when from 0 up to 9, these are points on the heap, which you know from your C course, C part of the course. So in this particular case, he calls the default constructor of point 10 times. And at the end, when you want to finish, you have to delete with the brackets here because the compiler needs it. If you don't have the bracket, he'll do something crazy, but we'll see in a moment. So we cannot call the other than the default constructor. So the only constructor in your new operator is the default. You cannot say point bracket open 10 bracket close and 10 20 or something. You have to then you would have to iterate in the loop, for loop over your array, and initialize, call the set functions for x and y. That's the only way to do it. Okay, we're almost finished, by the way. Watch out for the some tips. Watch out for the bracket operator with delete. As I've said, if you do not use the operator here to delete the array, he will only delete the first element, and after which he gives a runtime error. In the old days, it did not even give a runtime error, I believe. Okay, do not mix C allocation with C++ allocation. We've seen that in one of the demos, I think, in the course somewhere. I used the malloc, and he doesn't call it destructor. So if you're doing all sorts of funny stuff, I wouldn't mix it. So keep new with delete and malloc with free. And do not forget to delete memory, allocated memory. So it's more difficult than you think, because if you're writing big programs, somebody allocates memory, but you don't know when to delete it or who should delete it, because you don't know, maybe other objects are using the memory. Now, in order to resolve this problem, the new version of C++ is called C++ 11 or 0x. It's got shared pointers based on reference counting. So basically, we got a piece of memory. Let me draw it visually. So here's my heap again, my famous heap. I've got an object in memory. It's got to be deleted sometime by someone, but you've got lots of objects pointing to the memory. Yeah? So you don't know when to delete it. So I got object 1, another object, maybe more objects. So what happens is here, every time you create an object with a piece of memory, there's a so-called reference count. The reference count is incremented to 1 when the first object accesses it. So there's one object using it. If another object uses the same piece of memory, the reference count will be 2. And the third piece of memory will be 3. You see, so you cannot delete it because the reference count is greater than 0. If this object here says I don't need the memory anymore, the object count is knocked down. If the other object says it goes out to scope, I don't need the memory, the reference count is 2. And when the last object goes out to scope, the reference count is 0, which means nobody's using the piece of memory, in which case it will be automatically removed from memory in one of the destructors. So that's very good. So it alleviates your using new and delete with raw pointers, and basically it cleans up memory and it makes life a bit easy. So most people, it originally came from the Boost library. It's called shared pointers, smart pointers, and this reference counting. Later on we'll be talking about it, and most people in the financial world use smart pointers, or most C++ developers, unless you know exactly what you're doing and your problem is very well scoped. But for general financial applications, I mean, you don't want to be messing around with raw pointers, really, not always anyway, and smart pointers are pretty good. Okay, so we've given a summary of pointers. Let me go to my test program. Test program is a life cycle of objects, and I'm going through all the different scenarios. And I'm doing just normal things, but I'm doing funny things as well, and I'm forgetting to delete memory and so on. So I'm going to concentrate on the user defined type, because it's I've got in my destructor I got a print statement, so you know when objects are deleted or not deleted. In other words, from the heap. So I'm going to do normal things. I'm going to do extravagant things by not deleting the memory, and I'm going to see what's going to happen. So I've got a struct A with an integer. Struct is everything is positive or public by definition. Anyway, it's got an int just for fun. I have my constructor here with an integer. The default value is 0, so if you give no value, the k will be initialized to 0. I'm using the so-called colon syntax here. I've mentioned it a few times that you have to keep an eye on it. Instead of saying k is equal to val in the body of the function here, I just initialize k from val. Here's the copy constructor, of course. Copy constructor is I just every time I copy an object, it gets incremented by 2, just for fun. Now I'm going to go through all the scenarios, let's say, that we talked about in the slideshow just a few moments ago. Here's the first one. It's just very simple. I say A is appointed to big A, and I just say new A, so he calls the default constructor, and I delete A, so that should be okay. Now I'm going to the next one. It's the same as before, new A, but if I delete runtime error, if yeah, I don't delete A, so there's no runtime error here yet. It's the next one. If I do not delete A, your memory will be leaking because you haven't deleted it. Okay. Oh yeah, here's the runtime error. If I create an A, I delete it as normal. If I try to delete it again, so this would be runtime error. So you've already deleted something and you delete it again, you get a runtime error. Okay, phase 4 is I'm creating arrays, which I talked about. So let's take array size 4. Again, I'm saying array is appointed to A, new array n, and I delete one by brackets, of course, you see. Phase 5 is a variation of 4. Maybe it's better to say real-time debugging, or 4a. Yeah, 4a, because it's a variation. So here's 4b, whatever. So I'm creating my array in the normal way here, and everything is okay. You'll see that it's deleted 4 times. Here I'm not deleting my array, so there's a big memory leak. Oh yeah, here's my I'm just deleting just the first element. Here I'm not deleting it at all, which is terrible. So you got something like, was it 2 million, almost a big array, and you're not deleting it. Next one is I'm creating my A again on the heap. I'm assigning a pointer to A, B. So there's no memory involved, it's just a stack pointer. So there will only be one object created here. Now I'm creating the following. I'm creating a pointer to A, and I'm creating a normal object B as a dereference copy constructor, and you'll see that what's happening, that the 2 objects are created as well, 2 real objects. And the last phase is when I don't delete A, and here's another one when I have 2 pointers, I don't delete A. So there's lots of scope for experimentation. So let's run it, and you should run the code yourself. Just let me save all before I carry on. So let me run it. Okay, so off we go. Here we go. So it works. You can check here all the objects which are created. So you see here phase 4, whatever that is, that 4 objects are created, you see. Between 4b, no objects, for example. So what was phase 4, just as a check? page 4 was here, of course. So you created 4 objects on the heap and you deleted the 4 objects, which is fine. Now I'm going to do something awful here. I'm going to give a runtime error. Let's see, where's the example? Oh yeah, here we are. So we created an array of 4, but we're not using the delete operator, we're using the delete of the first element. So it's going to give a runtime error here. So let's see. Let's pray that it breaks down. Oh, he doesn't even give a warning. Okay, but he does give a runtime error. So you're getting all sorts of expression block type is valid heap. So they just, oh sorry, head is a block in use or something. So it's going all awful wrong. That's because I'm deleting the just the first element, okay, of my array. So there we are. Let me go to the last example. We stop here. I'm creating an integer. When the default pointer to a point, for example, or a user-defined type calls the copy constructor. Now I'm doing the following: integer. Let me call it pi as before. So it's a pointer. What's the value? If I dereference it, does it have a default value? So it has you just have a pointer, but there's no memory allocated. So when we dereference it, let's see what happens. Yeah, well, he gives you a warning. You can't say he didn't warn you. In this particular case, you see here, warning. Don't worry about the warning numbers. You can learn. This is part of it later on. You can learn numbers from your head, but. Uninitialized variable, yeah, it's fair enough. I mean, you haven't initialized it. So if I can actually initialize p to a null. So memory is initialized. So it is initialized. Let me see if it runs again. Well, let's see what happens. We probably still get an error message. Yeah, still uninitialized, of course. All sorts of bad things happening. So let me put it here, because you haven't initialized it before you're using it. You're using it. Camtasia is reacting. Okay. Okay, so now I assign it to null. So the pointer is null. So we see what happens to in the compiler. What he gives at runtime. Oh, it's already opened the file. Okay, that happens quite a lot. If you go down here, your file. You cannot, the executable cannot be written because it's hanging here, you see. So I have to close my executable, close my error messages, and the best thing is at this stage, when in doubt, just rebuild. Wow, it works. Okay, so now I run. Yeah, it gives an error message still, you see. So it's not so healthy. Let me see if the problem is caused by the cout. Okay, now it's okay. So the cout, there's something wrong here, because you've got no value initialized. So instead of saying null, I say pi is new int. Let's try it now. let's see what happens now. So we're getting step by step, we're experimenting, and this is the way I'd like you to experiment in general. To learn something, you try all the different scenarios. Oh, you get something ridiculous. You see, -8. It's a random number, sort of, some piece of memory. So basically, I just say pi. The dereference value is whatever. Okay. So dereferenced. Now let me run it. Pretty good, eh? You like it, eh? So the what I have forgotten here, well, I haven't forgotten, I just didn't do it yet. Every new should have a delete. So basically, you have to delete pi at the end, of course, eh? Otherwise, you get memory loss. Okay, so it looks okay. Okay, just for the fun of it, this is my last comment in code. I'm going to delete it twice, right? Okay, so it's wrong, of course. You've deleted it already and you're deleting it again. Well, it's your own fault. I warned you. Yeah, okay, which is what was to be expected. That's fine. Okay. That's my telephone going. Okay, so the let's go back to the original summary. The summary is the following. So we've given an introduction to heap-based memory management in C++, basically new and delete. And we focus on the life cycle of pointers. So you declare a pointer to some object or to some built-in type, and the pointees, this is the actual memory which you allocate. And so I've shown you by an example of source code which you can actually play around with yourself how it actually works. So as I've said, it's nice to know. You have to know all of this sort of stuff. You have to know it inside out. It doesn't necessarily mean you'll be using it every day in that sense. But in large systems, it is a big problem, memory management. That's why some people like Java, because Java does all the memory for you. So it treats you like a kid, whereas in C++ they treat you like an adult, right? Okay, but in large systems you do have memory problems, and because we basically do not know who the owner is of the memory. In this case, later on we'll see in the new C++ standard, we'll use smart pointers. So even for novices, smart pointers are to be used if possible later on, because yeah, the memory is taken care of for you automatically, and you've got enough to do. You've got enough on your plate to learn. So let's use smart pointers when you get the basics or the fundamentals up and running.